This video will look at an example of how do we use simultaneous equations to answer a word problem. So to use simultaneous equations to be able to solve a word problem, the first step is to define the variables if required. So sometimes the question will do that for you. Other times you will need to define what those variables are going to be. You can use X and Y, or you can use any other combination of variables you choose. Sometimes I find it easier to use X and Y because that is what I'm used to using. Step 2 is to write two equations for the information in the question. Again, sometimes this will be given to you. Other times you will need to develop those equations by yourself. And then step 3, after you have those two equations, go through and solve the equation simultaneously to be able to answer what the word question is asking you to answer. So let's have a look at an example of how we can use simultaneous equations to be able to solve a word problem. So in the example, it costs $3 for children and $7 for adults to attend a basketball game. If 5,000 people attended the game and the total takings at the door was 25,000, determine the number of children and the number of adults that attended the game. So our first step is going to be to define what our variables are going to be. And I'm going to use X and Y. So X will be the number of children. And Y will be the number of adults. So the next step is to come up with two equations from the information in the question. And we know that the total number of people attending the game was 5,000. So X plus Y is going to equal to 5,000. And we know that the total takings was 25,000. So if we times the number of children by $3, so 3x, plus the number of adults by $7, so 7y, that is going to equal to 25,000. So now we've got our two equations that we want to be able to solve simultaneously. So I can use the elimination method if I change my first equation so that it has a 3 in front of the x. So to do that, I want to multiply all of my terms by 3. So x times 3 is 3x plus y times 3, which is 3y, is equal to 15 times 3, which is 15,000. So now I've got a variable with the same coefficient in front. I can combine my two equations by subtracting one from the other. So starting off with my first equation and looking at the left-hand side, it is going to be 3x plus 7y, and then taking away the left-hand side of my second equation, so minus, and then in brackets, 3x plus 3y, and that's going to equal to the right-hand side of the first equation, so 25,000, minus the right-hand side of the second equation, so 15,000. So now I can remove my brackets, so 3x plus 7y minus 3x minus 3y is equal to 10,000. Looking to simplify, I can remove my 3x and negative 3x because they cancel each other out. And that leaves me with 4y is equal to 10,000. So to find out a value of y, I need to divide both sides by 4. So my y value is going to equal to 2,500. So now I can take that y value that I found out and substitute it back into my original equation of x plus y is equal to 5,000. So x plus 2,500 is equal to 5,000. To work out x by itself, I need to subtract 2,500 from both sides. So my x value is also going to equal to 2,500. So now I have determined how many children and how many adults attended the game. I can write my answer. So 2,500 children and 2,500 adults attended the game. And that is an example of how we can use simultaneous equations to help us to solve a word problem.